So I'm pretty pleased to be here. Pretty happy that I was, able to put together all of this great set of speakers, having them being part of this seminar that been working with Ed, trying to figure it out. The agenda, the best topics, and trying to find the best people for it. And I'm pretty pleased and pretty happy that you all could make it. You all could be here. If I can do a summary of what we've been talking so far, initially we discussed in what I said at the beginning of the seminar yesterday. The whole focus of that, and what I've seen many times in this bioenergy, biomass seminars, is really focus on conversion, right? How we can make a bioenergy product. But there is a little focus on the whole supply chain. So how we get the material, who is our supplier of the material, and then what do we do with it? What I tried to do with this seminar is trying to have a balance of the suppliers, the processing, making into a product, a bioenergy product, but also the environmental impact. And for all of us that have been reading through the DOE, USDA, and even the Department of Defense, they all focus on trying to understand what is the impact of any of the products that we make, what is the environmental impact of them. And Jesse did a great presentation as an introduction to LCA, and Jim was talking about the LCA and all of those. So it's happening, it's here, and we have to deal with it. So today, I'm just going to start talking about pellets. There's been a lot of discussion about pellets, a lot of conversation about pellets, and Helene just discussed briefly how the pellet industry is moving forward. And in Danny's presentation, there was some discussion about pellets and how pellets is impacting other industries, and how the production of pellets is moving into it. So what are pellets? That was probably the first question. So we have a compacted biomass. So basically, we're not making any change in the chemistry of the biomass. We're not doing any conversion in terms of the chemistry of the biomass, but it's just a pure physical conversion. So you densify the material. So basically, we took chips and sawdust and so on, and we compacted in a cylindrical shape type of material that is around 6 to 8 millimeters in diameter, and 38 millimeters in length. So a little tiny cylinder that is being used for the heat and power industry, and mainly the production in the United States is going to Europe, and I'm going to discuss those details later on. So it has two markets. It has a residential market, right, for heat, and it does have the commercial market for heat and power. So it is huge right now in Europe, and it's growing, still growing for the heat and power industry. So we can use pretty much any type of raw material with some limitations, and we'll get into the limitations. But we can use from round wood all the way, whatever size we want, to residues, to secondary industry residues. So we can have a furniture plant making sawdust, and out of that sawdust we can convert that sawdust into pellets. The beauty of the sawdust is already dry, and we'll get to the details about drying that biomass. So it is a bulk density. We increase the bulk density because if we just have a compacted material, the heating value doesn't change. It's at the heating value of wood, whatever wood we're using. But again, we are densifying that, so we're densifying the energy, all right? And we have two types of pellets or pellet market depending on the application, all right? So for residential applications, the ash content, it has to be less than 1%. For commercial application, it has to be less than 3%. The target for commercial applications in Europe, for instance, have to be around 2%. 2% is a premium commercial product in Europe, and that's where this is the focus of the United States. This is what we want to achieve in order to ship it to Europe. Can it be more than 3%? The commercial applications doesn't like it, so they're not going to buy it. You're not going to have a market to sell your pellets if they're larger than 3%. Can it be 3%, 2%, 1%? Well, value, this is where you play with the cost of the biomass. So you're going to be able to, you might be able to get a better price if it's less than 2%. So this is a general process. All right? This is a general production process, and what I like out of this diagram is, depending on the operations that we have, if we're getting just residues from a sawmill operation, or if we are getting the full logs, right? So the plant can operate on a different levels depending on what type of biomass that we're getting. So right now, all of these biomass, either from logs, debarking, the chipper, or just getting the chips into it, or getting the shavings in the sawdust, if they are not dry, if we're talking about green material, they are going to have some separation, some hammer milling operations, but basically goes to a dryer. Right? So all of that green biomass, no matter what shape we get it, it's just going to be ground down depending on the size that we get it, and it's going to go to the dryer. But also we can get material that is already dry, that doesn't need to go through a dryer. We go through a hammer mill, just fine grinding, just it should be a quarter millimeter, a quarter inch size, and then goes into a pellet press. Right? So if you see, the operations are not a large set of conversion processes. So basically we are grinding down a material, right? So reducing the size of the material, and then put it through a pellet press that goes to a cooler. And then here in the United States, we have two main operations. So a lot of the industries work either for the internal market, bagging. So they're doing a lot of bagging if it's for the internal use in the United States. If it's for export, they put it in a railroad car and haul it directly to the port, and then from the port to the boat and ship it to Europe. So throughout the different process, we can have, pre-treatment, and we can have a different steaming. We can add moisture. We can add additive depending on our own operations. Depending on the species that we're doing, some of the species might require some type of binders into it. So right now, for instance, one of the research I've been doing is the uses of binders for what I call second generation of pellets. So we know how to make pellets. We know how to convert biomass into pellets. Can we make it better? When I talk about better, is can I have a better process, or can I have a better pellet? So a product or a process. Can I improve it? It is right now, pelletization is a proven technology. We know how to make it. We know how to do it. You can buy a pellet plant right away. You can go to any of these large companies and you can buy a pellet plant, the whole plant. So can we make it better? And it's part of the research. Now, we don't know how to make pellets out of eucalyptus, right? So do we have some trials? Yes. Are any large facility already producing pellets out of eucalyptus? Not right now. Is that a potential? Absolutely yes. Well, it's not only eucalyptus. There are several species that we need to try, and we need to see if they can be suitable for the pelletization process. So this is an interesting comparison between pellets, briquettes, and liquid fuels. All right, and I'm not going to go through all of this because of time frame, but the idea is, pellets compared to briquettes. Briquettes are a larger pellet. They're not as compacted as pellets. really good. You can have a smaller or a larger size of particles and a more variety of things that you can compact, but you don't get such a good utilization of the handling of the material. So pellets are a lot easier to handle, so allows more automation into it. Investment for a briquetting is smaller. So what we have done in the lab, we do have a briquetter and a pelletizer, and we are, we're doing research to compare the two different compaction processes. But also, we have talked about the liquid fuels and the conversion and the limitations out of that. We talk about that it is a very expensive process compared to pelletization and so on. So yes, we might be able to solve different issues, different problems, but the investment required, it's going to be a lot larger into it. So here's a distribution of the cost, all right? So when we're talking about pellets, 38% of the cost is raw material. Again, looking into the discussion of the supply chain, so we discuss a very low cost raw material that we're getting into the pellet industry. So if we, cellulosic ethanol, start competing with that biomass and increase the cost of that, so we're increasing the cost of the 38% of the cost structure of making a pellet, all right? So it's going to be a huge impact into it. Now, the other huge impact is drying, all right? So what is the potential? So instead of having green residuals, so using dry residuals, it's going to be a lot better. It's going to be a easier one. Now, most of the time, dry ones are more expensive, all right? So a sawmill drying dust, it is more expensive than a green residue coming from the forest, all right? So the problem I face when we start doing all of this model is, can we have a specific value for each of them? And the answer is, it depends on the negotiation. So you have to go into a negotiation to figure it out. Well, I'm going to sign a contract with a furniture company for this much dry residues that is going to be able to be sustainable for my biomass plant, all right? Or a sawmill, or a forest residues. So it's not, we don't have any specific cost. We never get an answer for a cost. This is what is going to cost you the biomass in the next 10 years. And that's been the challenge for many of these industries. And you guys, you get companies coming all the time saying, how much is going to cost me the biomass in the next 10 years? Well, we would like to know. We would love to know that. But, in comparison, you see, this is without drying process. This is, we're talking about the cost of the pellet production per ton of dry, and this is including the drying process. So every time we add drying into our process, the cost is just going to go to the roof. So drying is a cost that we need to pay attention to it. Right? Either getting a biomass or a better negotiation with the biomass already dry, or how we can improve our drying process or utilize some of the heat out of that. And that's where a lot of discussion about or around torrefy wood came up. So can we just use a torrefication process to dry the material, to reutilize that energy, and then out of that torrefy process we're just going to be able to make pellets. All right? So what is the market? Now we know pellets. We understand pellets, how we make it, and some of the cost structures. All right? So it is a lot of, and I'm simplifying a lot this process because the making of a pellet, there is a lot of moisture content control and species and so on. And believe me, you can have a pellet press or a pellet plant with two same pellet press with the same biomass, right? Same process, same temperature control and humidity and so on, and you get two different pellets quality out of those, right? Exactly the same machines. Why? Nobody knows. Nobody knows. It might be, during the operations you didn't reach the right temperature. The temperature was too high or was too low. It dries too much the biomass. The flow of the material into the pellet press was different. So it does happen. So what is the market? 2009, right? And I like, and I agree with Jesse that Albert Einstein, all of the models are wrong, but they're the best that we have. And there's a lot of companies that are doing predictions about pellets. In 2007, this company, Vapor Group, they have a prediction about the market, the pellet market, and how that's going to change and so on. And the predictions were really surpassed by what really happened. So in 2009, this was the production, the consumption, and the exports of the United States. Right? This is million tons. Europe, obviously, Europe is the one importing a lot of biomass, so they do have a lot of consumption. And that's what Europe claimed that they produce, or that we're producing in 2009. And obviously, other markets, Brazil, China, and Russia, was trying to get into the game. And there's a lot of announcements, a lot of development, but there's a little, concrete and steel plants down there. So look at the projections, 2015, all right? So we're talking about United States producing 10 million tons, and the consumption is going to be 9, and the export is going to be 1, all right? So this is a prediction from Vapor. So consumption of 9. So they're predicting that the United States is going to start consuming pellets in a significant order of magnitude. So from 1.5 million to 9 million in 2015, right? So is that what is happening? Is that what is really happening into it? Not even close. All right? What is really happening is, yes, we are consuming a lot of biomass. We are producing a lot of biomass, but we are actually exporting that biomass. So we are not exporting 1 million tons of pellets throughout the United States. And I do have those numbers, all right? Don't get excited. So I do have those numbers, but the reality is, this is a perspective from Europe. This is what Europe is thinking. This is a European group. This is what Europe is thinking. So the key value here is Europe, it's going to import 9 million tons of pellets. All right? And we will have a presentation later on that based on the Agenda 2020, what is the actual need of Europe? What is going to be required that Europe is going to need to import of renewable energy? Okay? So all of those models, and probably they have a well-refined models into it, but all of those have to be, again, fine-tuned, and we have that discussion about it, that some of the data, some of the technology, some of the trends change, and we have to be aware of that. So this is history, and I like it because in 2008, that was not long ago, right? This is USDA publications. This is what we had. This is what we used to have in the United States. So most of the pellet plants, the capacity was around, 70,000 tons per year. So basically, we had a small pellet press next to, sawmills or next to furniture industries, secondary processing industries that were able to get all of that residues processed into pellets for more the internal market. So we were supplying this capacity internally, all right? So the large pellet press was about 150,000 tons per year. So that's what we consider large by 2008. That was 5 years ago? 5 years ago. Right now, our capacity, and we'll see that, our capacity, when we are talking about a large pellet press, we're talking about 500,000 to 1 million tons per year, right? So we changed the name of the game, of at least large pellet press, or a large pellet plant. Right. So we're talking about, right now, 500,000 to 1 million tons per year. So what are the prices? So we're talking, obviously, a distribution prices, and depending on the season, depending on the availability, depending on the market, and so on. So we can go from $160 per ton to $600 per ton, depending on the location. This is a U.S. prices. So average price was about $276 per ton. This is in internal market. What is the price of pellet right now? $220 per ton. About that. That was last quarter. So we're talking about a drop. This probably was 2009. A drop in price, right? But we're still exporting those. So everything goes to export. So the largest production, or the largest capacity, installed capacity in the U.S., it's focused on exports of it. Okay, so how everything is the whole pellet industry, we saw in the the largest producer exporter of pellets was Canada. Canada was making pellets in the West Coast and the East Coast. The largest one was the West Coast. They were using the beetle kill pine and some of those residues that they have in the sawmills processing. They were making pellets. Europe became a good market, so they were sending those pellets to Asia, but also they were sending those pellets to Europe. And Canada was the leader, or the leader in the market of inside of the U.S. Inside of the North America. That changed. So in 2012, we surpassed Canada. All right, just last year, our production and exports of pellets just surpassed Canada. All right, so we have the South. We have 1.5 million tons of pellets being produced in the South. This doesn't take into consideration all of the current plants that is being installed and all of the capacity. So something that really caught my attention is the huge install capacity that we are putting into pellets in the Southeast. It is impressive, all right? And Guillermo is going to talk about that. He did a study of production, consumption, and capacity, current and future, in the Southeast, right? Which is the largest movement of pellets installed in the United States. And it is interesting how we are increasing our capacity so much that I believe at a certain point we are just going to overflow the market with pellets. So how far we can go, and that's going to be a tricky question, how far we can go installing a capacity, so we're just going to be able to be, competitive and being able to make money out of that. So, well, it's actually going to be based on how much other countries are going to be able to buy, number one. Number two, it's the dream that we saw before, that our consumption is going to go to, 9 million tons in the United States, inside of the United States. which I'm not sure about. So we're talking about the Canada. It's going to expand. It has an expansion of 14% of their capacity. United States, it's increasing 13% capacity. We are building new ports. We're building new facilities. North Carolina is going to build a new port. There's companies like Enviva. Enviva is building two new plants. They already have one currently running good capacity. Fram Fuels, Georgia Biomass. There is a lot of projects and development and discussion. Now, coming back to one of the points that we discussed yesterday is all of that biomass that is there. There's a lot of companies coming from Europe installing all of these plants here, and there's a lot of unknowns. So tomorrow we might say, well, this is the best deal. This is the best business ever, without thinking about how many of them already thought about it, already are negotiating that, already have a land and already have a negotiation with, you know, a supplier or a plantation already, you know, being committed, and looking into the GIS map, we might believe that this is perfect, this is available, close to everything, and that might be already negotiated. All right. So there's a lot of information that within our, you know, even in the internal network, we don't even know that this is happening. So we don't know how many German companies are already negotiating facilities in the United States and where they are. So yes, they've been installed Southeast. It's been put into it. Now there is a big interest in Brazil to get into the game. So there are facilities in Brazil. They're working. They already have the plantations. They've been doing pulp. They've been doing pulp and paper industries. All of those, they know the plantations. They know the growing. They've been using eucalyptus and so on. So a shift into their business might be pellets, and they're talking about it. And there are a couple of companies that already announced that they want to do that. And if they get into the game, they're going to be competing with the United States. They might be cheaper. They might be a better, a more durable pellet, better heating value. Who knows? But if Brazil gets in the game, so we're just going to look into those competitors, not only the internal ones that are already in place, but also who's coming. So in order to deal with all of this, what we did and what we've been doing, and we've been learning good lessons out of that, we developed different models. So we were able to have a biomass flow, right? Balance and energy balance and economics. So we developed a financial, the whole mass balance of that, production rates, equipment, you know, the different facilities depending on the capacity and so on. We were able to obviously run the whole energy balance. So how much we're going to consume in terms of energy, that is actually both of them are related to the financials. So how it's going to cost to make it. And you know, this is a very interesting model, because people come to us and said, well, you know, I want to make pellets. I have a plantation, and you know, how long is it going to take me to be rich? Well, wish I can know that, but that doesn't happen. It's not that easy. So the whole market is difficult. A lot of people are coming to us, and let's say the beauty of pellets is you can have a fairly large capacity plant, or just the pellet press that we have in the university, all right? So we can make maybe 1 ton a day. Can you survive out of that? Well, it's going to depend on your business model. Now, the internal market is not that good right now. The good market so far, it's Europe. This is where the whole action is happening right now for the pellet business. So we were able to, understand raw material moisture content. Again, moisture content is extremely important for two things. It has to be controlled in order to make a durable pellet or a pellet that is going to be within the standards, but also the drying process. The cost in the drying process is very important. It's really high, right? So annual production rates and so on, getting into all the processes required, the energy required, the machinery, all the equipment, economies of scale change when you move to the traditional pellet press that was making 70,000 tons per year to all the way to 500,000 to 1 million tons per year. And then that it will impact the financial analysis of that. So there is a lot of automation into a pellet press or a pellet plant. There is a lot of material handling that is just being moved, processed, compacted, and conditioned. So there is the installation of that, all of that automation, and the cost has to be included into it. And then obviously we were able to generate all the mass equations and the losses and the yields and so on, the energy equations and the income statement, the balance sheets, and the capex. And all of that into a model, and this is where the coming to the lesson learned that Jim was talking about. We create a monster, all right? We create a model with so many variables and links and branches and stuff that you obviously trying to explain that model to a company, person, and so on was huge. And the idea of creating this model is having this available for the general public. So anyone can come to us and say, can I have with my hybrid poplar plantation, can I have a pellet press that is going to be economically feasible? Well, let me run the model, and you get into many variables. So what we had to do, and that was a very hard lesson learned, is we had to break, what we want to do was to break that model apart. So to get the model to say, all right, this is the hammer milling process. And the hammer milling process, this is the input, this is the output, the energy, and so on. This is the pelletization process. So like an operation unit. We failed miserable, all right? It was almost impossible to break that model apart. So what we did is to create new models. We already had the knowledge on it. So we create two models as a one Excel spreadsheet, all right? So we right now have the harvesting model, we have the drying model, we have the pellet model, we have the transportation model as independent models. So if someone comes to us just with a drying question, we can answer that question. But then we can integrate all the model into a one monster that is just going to be able to tell us from the biomass all the way to delivering pellets in Europe. All right? So it took us 2 tries, let's put it that way. But right now we have a lot more robust model, and Guillermo is going to talk later about the torrefication. He's going to talk about the the pretreatment conversion and the logistics into it. But basically, we were able to just combine all of those, and we were able to have a more accessible model for the different options and the different requirements of the customer. This is the model interface. All right? So we have different indicators that we can flip. We can have, the capital investment. We can have the financials. We can have what is the internal rate of return that we are expecting. What is the discount rate? So we can have all of that as inputs. The biomass that we're using in terms of the composition, the moisture content, the structure, and so on. Excuse me. We can have the different variables that we wish to change depending on the cost. And again, we can have a pellet press that is just going to cost us a lot more initially, but maintenance is going to be lower, and or a depreciation is going to be different. So we can't handle that. I mean, if you go out and you want to buy a pellet press right now, you can go from one price, low price, high maintenance, to a very high price initially, but a very lower or low maintenance later on. So it is like buying a car, all right? It is exactly the same like buying a car. So all of these machineries, they have a different options into it. And that's something that you can include in the model, and then you can obtain, different plots and different outputs and answers, or different answers for what you're looking for. So forecasts predict that growth will come, and we will see more numbers. We're going to be able to see a lot more numbers into it, but it will grow. The pellet industry, it's growing. For how long? We don't know, again. So we don't have that crystal ball that we were talking about, within the drawer, to figure it out for how long that it's going to be. But the reality is, so far, we do have a market. We do have established market. We do have established industry already in the United States. The most important one is the amount of new investment that we're getting into it. So this is not like, the paper industry is already a well-established industry in the United States, but you don't see that huge growth of it. So it's still being successful, but you don't see the huge growth. But you see a huge growth of pellet plants capacity and production and exports in the United States. For how long, we don't know, but it will happen. So we were talking about 3 companies already announced plans to open in Georgia. 6 are under construction in the south, adding 4.2 million tons of pellets by 2015. Do you remember those numbers all the way down there, that exports to the United States is going to be 1 million tons? Well, the reality, 2015, we are already announced from these pellets and from these pellet plants, we're going to be exporting 4.2 million tons of pellets per year. This is a large capacity. This is a big business. We're talking about a big business in the United States. Now, again, thinking about what we have discussed here is what is happening in the biomass part of this. Who are these plants competing with that are somehow, and as Jesse pointed out, it's affecting the other one? Yes, what is as a pellet producer, what is my responsibility? I'm trying to look into the life cycle analysis and my industrial ecology hat. What is, as a pellet producer, what is my responsibility in terms of my business is going to affect other businesses? And that's something that we need to pay attention, because we might get the chicken guy out of business because they're not going to be able to get enough shavings out of it. So no more chicken. So we're not going to be able to have, at least around a pellet plant, we're not going to be able to have chickens. All right? So this is thinking about that responsibility. Eastern and Western Canada, they are scheduled to grow. They're going to be competing For them, it's a good business as is for us. They haven't been as aggressive as us, but it is a good business and it is a good competitor. So if other countries, Brazil and China get into it, so we might be competing with countries that already have the infrastructure, countries that already have the business, countries that are going to be able to compete with, in terms of price, with the United States. They do have the resources as well. So is Europe going to need it? Yes. Finally, I don't want to run out of time. I want to thank WERC for sponsoring this wonderful seminar, being able to put together with all of these great speakers and friends. And we see each other around, but we don't talk much because we're always busy. The Department of Forest Biomaterials, Forestry, all of the extension guys appreciate it. And this is a Biomass Bioenergy Center, a service center I've been leading and trying to get into the whole pellet industry and trying to get more knowledge out of that. Questions? And I think I'm in charge of the mute, so. Yes, Dennis.
Three twice classified, trying. I just assumed that the pellet companies would work for fuel for drying. Is that not?
Yes and no. So the model have a different aspects of that. The large facilities are producing some of the bark get into the pellet, all right? That's this is a very low value material that goes into the pellet up to the point where ash content has to be less than 2% in order to make money, good money out of that. Some of them, they do have boilers and they do generate electricity. It's not going to be enough. But this is the cost structure. So no matter what, either if we produce it internally or if we buy it from the grid, this is how much it's costing us. So we might not have the profit margins and so on, but the drying in terms of energy consumption and cost, just look at it as how much energy we put into it and how much it's costing us, no matter where it's coming from.
It could be an internal cost.
It is a cost coming into making a single pellet. So that's what is in there. Sure.
So 9 million tons internal use in the U.S. Why not? Why aren't we using it? Oh, it's a terrific fuel. Why isn't it tried on here in the U.S.? We'll catch on.
I think the business developed around European policies, right? So they've been forced to do it, and they have to do it. So that's what they are pushing for. So they were paying good money out of them that we might not, the U.S. might not be paying for that type of conversion and so on. We do have some conversion, but instead, we're still having a very low-cost coal that we're using. So why bother? So if we have a very cheap, more higher energy content out of that. Remember, we're buying this fuel in gigajoules. So we're buying in terms of energy. So how much energy you can get out of that. So that's one of the drivers. So we need the policies. We need to enforce those policies out of that.
Jim, to follow up on that, out west there was a huge push for pellet stoves several decades.
Mm-hmm. Mm-hmm.
And so there was a mature industry that was delivering that to individual houses for self-heating, basically. Now, when some of the environmental concerns came up, were smog related. It was cold air inversion that would trap the smoke in the valleys out west. What policy mechanisms didn't help with that, but there used to be a relatively mature, smaller scale industry in the U.S., and in some ways that might actually be disincentive because of past experiences in the
Yeah.
industry towards now those atmospheric conditions are different in east or anywhere you don't have mountains.
Mhm.
But those might be some of the things that are kind of related as to why it hasn't gone on fast, but we have a demonstrated capacity to tool up and produce and use those kinds of technologies several decades.
And this is residential.
And that was residential.
We haven't touched the commercial one.
Right?
And maybe, nuclear, it's cheaper.
If you consider residential, the lines are green, which you would be aware of.
I mean, they were great. The people that adopted them out there, and they were fantastic until we started running up against the burn ban issues because burn bans actually did not apply to pellets. So it's cleaner than firewood. So firewood got banned first, and then pellets were exempt from that. So there's a nice potential market there, residential, but that could also go commercial. And commercial, then you can afford to put a stack up to get it out of the inverter.
Yep.
So there might be a lot more
Yep.
potential for the commercial application.
I don't know what's going on or how long Europe has been using pellets, but they're set up really well with their infrastructure as well. The houses, the residential use for it, they've got hoppers already set up, the truck goes in there. If they don't buy bags at all, everything's done. So a hopper.
Yeah, you have the house in Sweden where you get a truck that just put pellets into your silos, and it is an automatic system. So when you adjust your thermostat, you just basically bring in more or less amount of pellets into it. So it does have a mindset also, right? So Europe being more using the biomass as a resource for heating and power and so on. We haven't used it that much. We've been addicted to fossil fuels. And that's what we've been using. So we're addicted to it. So, yes.
mentioned the importance of moisture control. That if you start with 5% moisture control, 10% moisture, I like to have a moisture content of that.
Well, the moisture content it has an influence throughout the whole process. So initially we have to reduce the moisture content, and the reduction of the moisture content is based on the pelletization process. In order to reach the right temperature to make a pellet, a durable solid pellet, you have to reach certain temperatures. If you have too much water on it, you're going to be evaporating. So basically the water is just going to be absorbing that energy, and it's not going to be able to make a good pellet, right? A consistent, durable pellet. So what we have is a drying process and getting into the pelletization process, and it has to be between 10 and 12% moisture content during the pelletization process. That's the range on pelletization. That's the operation range for moisture content in pellets. But then when we get out of there, the pellet is not hydrophobic. I mean, the material is just being wood compacted, so it's going to absorb moisture. So if you have high moisture content ambient, right, or environment, the pellet is going to absorb that water. It's going to absorb that moisture, and at a certain point, it's going to expand and it's going to break. All right. So you might have short pellets which are not desirable in the process. You might have fines. It's part of the thing. So you might affect the durability of the material.
It depends on
Yes.
the environment. But if you environment, people moisture content 5 to understand that drying energy
Mm-hmm.
section is still and for 5% one drop. Final cut of different.
No. It shouldn't. It shouldn't.
Final cut of the same.
It should be the same. It should be the same.
The proof that
You gotta, yeah, absolutely. You gotta tweak the moisture content to reach those, range moisture content in the processing. But if you get, southern yellow pine at 50% or 10%, it's just gonna be a matter of having both of them at the same moisture level before getting into the pellet press. But you don't have changes. I mean, it's not gonna be different pellets. You're not gonna make a different pellet out of the two different moisture content input biomass. Yes.
Kind of alluded to production capacity dictated by government policy. That bubble first.
Okay. Right. I don't want to steal the thunder of another presentation, but because I know but the reality is Europe, based on their policies, it's going to require a lot more biomass that they actually produce and that we actually have. All right. So based on the Agenda 2020 and all the conversions that we have done, they're going to require a lot more. So the business, it is a bubble, right? And it is a bubble that if Brazil and China and so on start getting into that bubble, we might just burst that bubble at a certain point because we're going to have too much installed capacity for the demand. So far, what the numbers that Europe have shown are promising. The problem is it's policy driven. So if tomorrow they decide to change the policy or be more flexible in Agenda 2020 about that 20%. So I think the Agenda 2020 was not the first one, but was the first one that really enforced all the countries to do the 20% renewable portfolio. The problem is that 20% is that 20% renewable bioenergy is realistic. If it's not realistic, I'm guessing, and this is my personal opinion, in January 1st, 2020, they're going to look at the numbers and want to say, we were wrong. We're not going to be able to achieve this. So we better change it, be more flexible, do adjustments into it. So that's what I'm really afraid of that. If we are not able to achieve that 2020, the Agenda 2020, and they change the rules, they change the policies, so that's going to affect us because we already have all of that plantations and we already have all of that facilities and we already have all that infrastructure already built, ready for a Europe that is not going to buy it. So hopefully we're going to be able to sell it, but we triple our capacity. And Guillermo is going to talk about that. Well, we increased our capacity significantly. It's a huge number in the last 5 years. So yes, it is a bubble. I don't think we're close to explode, but be careful if they change the rules. If they change the rules, we might, the bubble that can collapse on us. It could be. It could be before. It could be in 2018 they realize that they're not going to be able to get to the 2020, and they may change it. So, yes.
In terms of, you were discussing some pellet production in Brazil. You mentioned that their primary feedstock would be but you also mentioned that that's not a very good feedstock for making pellets. I was wondering, have they already developed some means of using a binder? In order
What do you mean it's not a good feedstock for?
I thought you said that it didn't compact well.
Oh, no. It's good to make pellets.
Oh, really? Oh,
Yes. I mean, we have done Bentamii, MacArthurite, Grandis, several eucalyptus trials that have around the United States, and we've been able to make pellets.
That's okay.
Yeah, and we have, and you can look at it, some of the papers. We have published papers in doing the economics of making pellets out of eucalyptus. That's can be done. That's not a problem out of that.
Europe doesn't want binders
Well-
anyway.
Unless they're natural. The problem is, I don't think they're willing to pay the premium for a binder. See what I'm saying? So the binder, it's going to make the product better, the process better, but it's going to cost a little bit more. And I don't know if Europe is ready to pay that extra premium for a better product, if what they have so far, it's good enough. Any more questions?
Just sure, real quick, the briquette
Yes.
industry, does that require a binder? Or they can get that compressed enough where it's holding up?
Yes. That the density is not as high as pellets. It doesn't densify that much, but you're more flexible in terms of moisture content and particle size. So the pre-processing of the material, it's easier and it's cheaper with the briquetting, but the volumes and the handling of the briquette, just because of the size, is too bulky. So there's some improvement trying to make a silver dollar shape type of briquette, and that's going to be a lot easier material handling in terms of material handling consistency in burning. Because in terms of transportation, they will pile up better. So you might optimize or improve the transportation, the volume. So you will match
You have
up by.
something really stacking those briquettes nice and tightly on a lot of airspace.
Yeah, those are the rectangular shapes and the square shape, but the problem is they're bulky. They're not easy to, they're not good for automation.